Now let's move on from the heart rate calculation and actually determine the regularity itself. Whenever we talk about regularity, first of all, you want to try to figure out, is it regular or is it irregular? You want to look at two consecutive R to R intervals. You're going to take your calipers or a sheet of paper, you can do that too, and determine the distance itself. If you use a sheet of paper, what you can do is you can actually put little marks on the sheet of paper here, and then you can just move the sheet of paper across and then compare those marks with that one and with that one. That's the most common way that a lot of people do it. If you use your calipers, you can just set the tip of your caliper on one and set your tip of the caliper on the other, and then just flip the calipers over and then flip the calipers over. You can just flip them over to actually check your regularity. If the calipers are all falling in the same or similar distance, then it's actually considered a regular type rhythm. If they're considerably different, then it's actually considered an irregular rhythm. This is just some examples of a regular rhythm. These rhythms are regular, and basically what that means is the rhythm strips, or I'm sorry, the rhythms P wave and QRS complexes march out throughout the strip. Now in this case, we're not actually using the QR or the P waves, we're actually using the QRS complexes. And as you can see, the QRS complex, it is actually, they counted it out for us, which was nice of them. This is actually occurring at 56 little boxes between each QRS complex. Since there's 56 between each of them, I'm going to probably bet that if we go all the way over here to the right, there's going to be another 56 over here, and if we go all the way over here to the left, I'm sure that there's going to be another 56 over here, not 156, but another 56 over there. I'm betting that this rhythm is going to be considered regular. If you were to take your calipers, you could actually count between or use the measurement between the QRSs, and it would also come up as regular. This rhythm, as you can see, is considerably faster. Fortunately, they were nice enough to count them out for us again. So we're going to have 9 little boxes, 9 little boxes, 9 little boxes, and as you continue out, all of these are going to be approximately 9 little boxes all the way across. Now, sometimes you might end up with one that's actually going to be 10 boxes. One of them you might end up with 8 boxes. This is not a big deal if you're varying one way or another from the 9, which is actually the standard in this case. It's still considered regular. This is another example of a regular rhythm. The only thing is you have to actually look and find your point, your start point, and then where you're actually going to go. In this case, you can actually, this is your QRS right here, which is kind of odd, and then this is your T wave. So you can start here and then go to here and then go to here, and what you actually end up with is 11 boxes here, 11 boxes here, 11 boxes here. As you go across, all of these, of course, are going to turn out to be 11 boxes. For an irregular rhythm, you have to consider that the underlying rhythm is regular, but you might have an irregular beat, but there is no real pattern to the irregular beat. This would be considered irregular. Please remember that an irregular rhythm, the underlying rhythm is regular. You just have an irregular beat. If you look at the first rhythm down here on the left, don't worry about this occasionally part. I don't want you to look at that. I just want you to look at this. There's 14 little boxes here, 14 little boxes here. There's 11. There's 16.5, which means that this right here is a premature beat, but then you go right back to 14 little boxes between the QRSs. If you take your calipers, what would happen is your caliper would actually end up somewhere over here. It would end up off from this actual QRS complex. The important thing here is that the underlying rhythm is regular. It is an irregular beat that made it an irregular rhythm. Now let's go ahead and look at the rhythm on the left, on the right side over here. As you can see, we have 16 little boxes here, but then there's 12 little boxes from this QRS to right about here where this QRS is. Then we have a pause over here where it's actually 21 little boxes. If you were to march this out with your calipers, what would happen is your calipers would probably end up somewhere over here, and it would show that this is actually a premature beat. Once again, the underlying rhythm is regular. It is just this one ectopic beat that actually makes the difference. Now let's discuss something that is regularly irregular. A regularly irregular strip means that there is a patterned irregularity to the strip. This does not mean that there is an underlying rhythm that is regular. The entire strip is irregular to itself, but you can definitely see a pattern. In this case, we can see a pretty simple pattern. We have 3 QRS complexes that occur right here in normal, what looks like we have a 22 little boxes, 19 little boxes, and then we have one here. Here we have another 3 QRS complexes right here, this grouping here. Now, this one right here is 21 boxes. This one is 22 boxes. That's not a big deal. I'm not worried about a 1 box different. This is 19 boxes over here. If we come up, that's 20.5 boxes. Well, I would probably count it 20 boxes. That to me is not a big deal. They're very similar to each other, which means that this is a grouping. Now, the underlying rhythm is not regular because there is no way to march this out all the way through. But I can see that there are patterns here. I bet if I were to print up even more of this strip over here, I would once again see a beat, a beat, a beat, and then a pause. And then I would see later on in another part of the strip, a beat, a beat, a beat, and then another pause, which tells me that this is a patterned irregularity, making it regularly irregular. Now looking at the irregularly irregular, we're actually going to see that there is no pattern whatsoever except by accident. Now, if you look at this rhythm, they were nice enough to actually march this out for us and give us our little boxes in between. With your calipers, you can do the same thing. There's 9.5 little boxes here. And then we jump way up to 20. Then we're back to 9.5. Now, even though this 9.5 and this 9.5 are similar, these are the only 2 9.5 millimeters between these boxes that you actually see. So this doesn't mean that it's a patterned irregularity. There's 11.5, 8.5, here's a 9.0, and then as we move further over, we actually end up with another 9.0 with all these different numbers. Now this 9.0 and this 9.0 are the only 2 9 millimeter differences here, so this does not make it a patterned irregularity. As you can see here, all of these numbers are all over the place, which tells me that there is absolutely no pattern at all except by accident, which is actually what is going on here. There's only a pattern by accident. So since there is no pattern whatsoever, I'm going to go ahead and classify this as an irregularly irregular strip. Commonly, you will see these type of strips in people that have an atrial fibrillation, a rhythm strip of a wandering atrial pacemaker, and sometimes a multifocal atrial tachycardia. These 3 types of rhythms we will actually cover later on in an atrial rhythms, in our atrial rhythm presentation. Now let's go ahead and assess the P waves themselves. Let's look at the P waves. Whenever you look at the P waves, what you want to try to do is you want to determine, are the P waves uniform? Are they preceding each QRS complex? And do they appear normal? Well, what is actually considered a normal P wave? If you remember, normal P waves should be upright and they should be smooth and round. The duration of the P wave should actually be less than 0.10 seconds, and this will be more important next semester when we start talking about 12 leads. This is not as much as an important thing now, but it will definitely be next semester. Is the P wave married to the QRS complex? What that means is, does the P wave cause that QRS complex? There are times when you'll have a P wave, but it will not actually cause the QRS complex, which means this atrial depolarization did not cause this ventricular depolarization. Now, most of the rhythms that you will see, the P wave will be married to the QRS. Now, let's look at the P wave here and see if it actually falls within normal limits. Does this P wave right here, is it smooth, round, and upright? And the answer would be yes. So we actually meet this criteria right here. is the duration of this P wave less than 0.10 seconds? And the answer would be yes. If you actually look at it, it starts here and it actually ends here. So the actual duration of it is going to be 0.08 seconds. You're not going to actually have to measure the P waves on rhythm interpretations for quizzes. You just need to know that it's less than 0.10 seconds. Now, is the P wave married to the QRS complex? And in this case, yes, it is married to the QRS complex, which means this P wave causes this QRS complex. So in this rhythm strip, the P wave is normal. Now let's assess the PR interval itself. You want to ask yourself, is the PR interval normal? Does it have normal limits, and is it constant in duration? That's the important thing right now, is it actually constant in duration, because there are going to be rhythms that we're going to look at that the PR interval is not constant, and that goes into part of your rhythm interpretation. In this case, we're going to look, we've already assessed the P wave. In this case, they've already measured out for us that the P wave, the PR interval, I'm sorry, is actually 4 little boxes. 4 little boxes tells us that this is actually 0.16 seconds. Now remember, the normal P wave, PR interval, is supposed to be 0.12 to 0.20 seconds, and that interval actually falls within the proper range. If the PR interval is outside of that range, it means that there are some kind of impulse problems, taking a different pathway, or it could be delayed through the AV junction. Both of these are actually going to be rhythms that we're going to cover later in class, so I'm not really worried about you learning exactly the cause of PR intervals that are outside this range. Now let's go ahead and assess the QRS complex. This can be a little bit more complicated, but we're going to go ahead and give it a shot. Are the QRS complexes within normal limits? And do they appear normal? Well, what's actually considered a normal QRS complex? If you were to look at a normal QRS complex, you would actually see that the QRS complex actually should be narrow, and it should have steep angles with sharp points. Now, in this case, you look at the QRS complex here. Is this QRS complex normal? Yes, it is, because you actually have your time frame, your duration of your QRS complex is 0.06 seconds down here. A normal QRS will occur less than 0.12 seconds in duration, which is less than 3 boxes. It's 3 little boxes exactly, which is what this actually falls into. Now let's look at this let's look at this QRS here. Does it have steep angles? Yes, it does. Does it have sharp points? Yes, it does. So because these QRSs actually meet all 3 of this criteria, that means that the QRSs are normal. Later on, you're going to learn about abnormal QRSs, but for right now, you just need to know, are they normal or are they abnormal? Let's go ahead and look at a couple abnormal QRS complexes. One abnormal QRS complex, we're going to look down here at the rhythm on the left, and you're actually going to see. Now, you could say that this actually has steep angles with sharp points. So you can say, yes, it has steep angles. You can also say, yes, it has sharp points. But if you were to actually measure the QRS duration, it starts here and it ends over here. I would say that it is actually equal to 0.12 seconds. Now this is kind of borderline, but I would go ahead and say yes. This is actually equal to or greater than 0.12 seconds. It's considered wide, so it is not narrow. Automatically that means that this is not a normal QRS complex. If we look at the rhythm strip over here on the right, you will actually see that there are QRSs that are right here, and they're measuring the QRS at 0.15 seconds, which is obviously above the 0.12 seconds, so it is not narrow. Does it have steep angles? Well, yeah, you can kind of say it has steep angles. It would be nice if they were a little bit steeper. This point right here is a little rounded, but even if you want to say yes, it is steeply angled and yes, it is sharply pointed, it isn't narrow. So you still couldn't say that these QRSs that occur in the rhythm down here on the right are actually normal QRSs. Just as a quick reminder about the difference between a Q wave, an R wave, and an S wave. A Q wave is the first negative deflection that occurs after the PR interval or the P wave, depending on which one you look at. It's actually the first negative deflection following the P wave or the PR segment. An R wave is the first positive deflection after the Q wave, if there is a Q wave, or after the PR interval or the PR segment if the Q wave is actually absent, the first positive deflection. The S wave is the first negative deflection that extends below the baseline. That's actually the key phrase here. That's the key part of the phrase. It has to extend below the baseline for the following the R wave. That is actually what constitutes a true S wave.